Welcome to the next session on ANSYS Workbench tutorials. In this session, we are going to analyze the compression bone plate for transient thermal analysis. We have done the steady state analysis of the bone plate. Now we are going to do the transient thermal analysis. Transient thermal analysis is used when your temperature varies with respect to time. So we will see what happens to the bone plate when the temperature is varying with respect to time. We will start by double clicking on transient thermal. First we'll go to engineering data. I am going to create a material that is stainless steel of 316 grade. In case you are using a version which already has this material, you can directly add it. Since my version doesn't have the material, so I will add the material here. Now I am going to give the property of isotropic thermal conductivity in terms of watt per meter Kelvin. The value is 17. Here you can see the density value is also being asked, so you can just give the value of density if you have it with you. In terms of kg per meter cube, it is 8070. Now I'll go to project and update project. Next I'll go to geometry and right click. I already have the model made with me. You can go through the video where I have already shown you how to make the model of compression bone plate. So I will directly import the model. Next I'll go to model and double click on it. First we'll go to geometry and change the material to the one that we have created. Next I'll go to mesh and I'll change the sizing to fine and update. Next I'll go to analysis settings and I'll change number of steps to 10. Current step number is 1 and step end time is once again. Auto time stepping is program controlled. I'll change it to on. When these options open up, I'll give the initial time step to 0.1 second. I'll give minimum time step to 0.1 second and the maximum time step is already 0.1 second. So you can see the time is now changing from 1 to 10 seconds. Next I'll go to transient thermal and insert temperature. On this side, say it is exposed to the blood. So I will click on the side and I'll give the temperature highest value as 37 degrees Celsius. The initial value is 22 and the second value I just make it to 22.8. Make the first one is again 22. So this is how the temperature is varying. Next I'll insert convection over the body. And now I'm going to select the entire body for convection and apply. For fill coefficient, I will choose import temperature dependent, stagnant air, horizontal cylinder. Okay. Next I'll go to solution and I'll insert thermal temperature. I also want to see the heat flux over the body, that is the total heat flux. And I want to see the heat flux which is directional, that is along this axis. You can see the axis is Y. So I just change the orientation to Y. Then I'll go to solution and solve. We'll first go to temperature and see the variation. I will change this option to no wireframe from show elements so that I can see the results very clearly over this compression bone plate. Now if you observe, I have taken the bone plate which has 6 holes. I'll give you the geometry for this. You can download and use it, or you can also create this geometry based on the video wherein I have shown you how to make this plate. So you can very well see the temperature variation. Now when I see the minimum temperature, it is almost similar to the maximum one. So I can click on either one of the two in this graph. I can right click and export the data and save it for my results. And you can see that the time is varying and so is the temperature over this plate. I have given 0.1 second as a difference and the time is varying from 0 to 10 seconds. So this table gives you that value. And this is the graph which is obtained. So you can save this graph as well. And we can just animate and see the variation of temperature over the plate. We have given thermal conductivity. K value is 17. So this is how the conduction takes place over the body. Had the conduction been more higher, then obviously you will see more variation of temperature over the body. Next is the total heat flux over the body. The value is 0.000227 watt per mm square over the body. That is the highest value at these points. You can see here. If you want to see the max min, just click here. You can see max and min here. You can click on probe and get the value at whichever point you want. Say at this end, at the center I want to see the values, I can just click here. If I don't want to see these values, I can just right click, delete all. And if I don't want to see the maximum and minimum value, just click on max and min once again and also on the probe. So all the options have been unhighlighted. Now we can just click on minimum because that is showing some different value over here. So I just show the maximum value and I can see the result. You can also choose the minimum value. It is your choice which value you want for your comparison purpose of this result. Now comes the directional heat flux, which is very important for us because we want to know that if the temperature is highest here, then how much heat is being transferred and at what time, which is most important. Say once you place the plate and within this time difference, what amount of heat is transferred from one end to the other end is what you can see here. Now I can just unhighlight the green one. You can see the red one. You can see the graph. It is in the downward direction because it is showing in the negative y-axis. It is showing upwards if you see, and downward direction is plus y. So that is why this is showing a negative trend here, and these are the negative values. Otherwise it would have been positive. So do not bother about this sign, it is just showing a direction. And the value you can see is minus 4.94 into 10 raised to minus 5 watt per mm square, which is the highest value. You can again animate and see the result. So with this, I end the session. I hope you understood the analysis. It is very simple, but it is important to understand how to interpret the results obtained. If you have any doubts, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.